The topic for Lesson 1-7 is logical reasoning. You'll learn to identify the hypothesis and conclusion in a conditional statement and use a counterexample to show that an assertion is false. How is logical reasoning helpful in cooking? Popcorn is a popular snack with 16 billion quarts consumed in the United States each year. The directions to the right can help you make perfect popcorn. If the popcorn burns, then the heat was too high or the kernels heated unevenly. The statement, if the popcorn burns, then the heat was too high or the kernels heated unevenly, is called a conditional statement. Conditional statements can be written in the form, if A, then B. Statements in this form are called if-then statements. The part of the statement immediately following the word if is called the hypothesis, and the part of the statement immediately following the word then is called the conclusion. Okay, remember they said the hypothesis comes right after the if, so it's not going to include the if. So identify the hypothesis. The hypothesis will be, it is raining. The conclusion follows the word then, so Bo and Chloe will not play softball. Now, of course, you'll need to write that out, hypothesis, and you could abbreviate that for an H. It is raining. Conclusion, a C would work fine. Bo and Chloe will not play softball. Again, identify the hypothesis and conclusion. And again, the hypothesis comes right after the word if. So our if is 7y plus 5 is less than or equal to 26. So after if, so that's the hypothesis. And the conclusion comes after the then. So then y is less than or equal to 3. So again, an H will work for hypothesis and a C for conclusion. The hypothesis came after the if, the conclusion came after the then. Sometimes conditional statements are written without using the words if and then, but you can always rewrite them so it's in the if-then form. So here it just says, I eat light meals. So we had to rearrange it a little bit grammatically. The hypothesis would be, I'm eating a meal. And we could conclude from that, it is light. So in if-then form, if I eat a meal, then it is light. Again, it's easier to work with if it's algebraic sentences for a number a such that 8 plus 5a equals 43, a equals 7. Well, there's my conclusions kind of jumping out at me, so the part that's not the conclusion must be the hypothesis. So if our hypothesis is 8 plus 5a equals 43, and our conclusion is a equals 7, then the if-then statement would be, if 8 plus 5a equals 43, then a equals 7. Deductive reasoning is the process of using facts, rules, definitions, or properties to reach a valid conclusion. Suppose you have a true conditional and you know that the hypothesis is true for a given case. Deductive reasoning allows you to say that the conclusion is true for that case. Determine a valid conclusion that follows from the statement. If one number is odd and another number is even, then their sum is odd for the given conditions. If a valid conclusion does not follow, write no valid conclusion and explain why. Okay, they gave us two numbers, 5 and 12. The hypothesis said if one number is odd and another number is even, okay, so 5 is odd and 12 is even, so the hypothesis is true. So since the hypothesis is true, we can conclude that the then part will happen. The conclusion, the sum of 5 and 12 must be odd, which of course it is. Okay, so we're starting off with if one number is odd and another number is even. This time the two numbers are 8 and 26. 8 and 26 are both even numbers, so the hypothesis is false. Wah, wah, wah. That means we get no valid conclusion. If we don't meet the hypothesis, we don't get to talk about the then because the if isn't true. Now we don't get to reverse the order on this logic. Suppose the conclusion of a conditional is true, this does not mean the hypothesis is true. Consider the conditional. If it rains, Annie will stay home. If Annie stays at home, it does not necessarily mean that it is raining. Maybe she was watching TV and couldn't possibly leave the house. I don't know. To show that a conditional is false, we can use a counterexample. A counterexample is a specific case in which a statement is false. It takes only one counterexample to show that a statement is false. Find a counterexample for the conditional statement. If Joe does not eat lunch, then he must not feel well. Well, maybe he ate too many snacks. Maybe he just wasn't hungry. I mean, there's lots of different counterexamples you could come up with that. Find a counterexample for the conditional statement. If the traffic light is red, then the cars must be stopped. I don't know about you, but I've seen sometimes cars run red lights. Emergency vehicles, and they should be running a red because there's a fire somewhere or ambulance. Okay, so again, more than one choice for a counterexample. Which numbers are counterexamples for the statement below? And actually using for counterexamples is a great way. It's kind of a guess and check thing that you can do on multiple choice tests. Well, let's just start with A and see if it works. So x is 2 and y is 3, and it's not supposed to equal 3 minus 2. So I have -1 does not equal +1. Ooh, that's a true statement, so that is not a counterexample. Keep going, let's try B. So we're going to do 4 minus 4 does not equal 4 minus 4. Aha! 4 minus 4, in fact, does equal 4 minus 4, so B would be a counterexample. And we could keep going with C and D, I guess. C, we'd have 0 minus 1 equals 1 minus 0, -1 equals 1, and it does not equal, so that's what it's supposed to be. So that is not a counterexample. And D, 7 minus -7, I'm just going to write +7, does not equal -7 minus 7, and of course 14 does not equal -14. So the one that's the counterexample was the one where they did equal because we wanted it to be not equal to. Conditional statements can be written in the form if A, then B, where A is a hypothesis and B is the conclusion. One counterexample can be used to show that a statement is false because it's not always true.